Okay, so I got a student request a few minutes ago to do homework problem 18.21. It's about the commutator, which is the angular position operator and the angular momentum operator, and that's the commutator. That's the way we do this commutator language. By the way, look at example problem 17.1 if you need review on commutators. Okay, for review on commutators, look at example 17.1 because this is built very much the same. So, when I look at a problem like this, first, if I haven't looked at it for a while, I need a review, right? What is the angular momentum operator? I go look that up. That's on page 419 or maybe 418, and it's here. Okay, that's in the question stem, but that's what it is, okay? And we use that symbol for it. It's used for z, sub z, on when it's talked about on page 418 or 419. Yeah, that's a good question, why? Why is it z, and why did I not have that there when I first began? Okay, because I'm going to ignore that z a lot of times. Why? Why z? Okay, it's a good, it's closer to than you might imagine. They're playing. Okay, then the second one is the angular position operator, which is simply phi. Okay, there's the operator, and that's the operation. So, and that's exactly what we have here. So the question in question 18.21 is, can we simultaneously know or measure both the angular position and the angular momentum? And the answer is no, because it's on page 419. Or it's no, because it's just like the position vector and the momentum vector in a linear system. But the sophisticated way to answer this, and the question leads you through it, is evaluate the commutator. If the commutator is such and such, then they will commute, and then we can know them simultaneously. That's really important. If it's what? Oops, put a 0 on there. Okay. Alright, if it's 0, then we say they commute, and that means that we can know them simultaneously, or we can measure them simultaneously. I started to say, what is it supposed to be, and I accidentally put the 0 there. So, anyway, but that's an important question that you ought to be able to answer. That's weird wording, okay? So I say that to you who are looking at these problems and saying, what's really being asked here? And you have to be thinking about that a lot. If it's 0, then they commute, and we can blank. Alright, so let's evaluate the commutator. And the way to evaluate the commutator, a definition in chapter 17 goes like this. You give some operator A and an operator B on some function. If this is equal to B operating on a first, or rather A operating on a first, and then B, if these are equal to each other, then we would say that these guys commute. And that makes sense, right? You can see the commuting, like this guy's commuting outside of the bracket, this guy's commuting inside it. Okay. And then we'd say they commute. Okay? So this is the same thing as saying if A, B minus B A hat of F is equal to 0, right? That's the same thing as saying that. So what we're going to do is we're going to evaluate commutators. We're going to find out what A, B, we're going to find out what this is. And this is the B, A. I'm just writing the same thing, I guess, over and over again, aren't I? We're going to find out what that is. And that is the commutator. And the language that we use that with is, the notation that we use for that is this. That's how we say it. Okay? Brackets A hat, B hat. Alright, so let's do that with this one now. And we're doing it with this one here, so let's take this with an arbitrary function. And that's going to be, the inner one is minus I h bar d phi of some arbitrary function f. It's a function of phi, but I'm going to leave that out for now, if you don't mind. And then operating on that is the other operator, phi. Okay? Minus I h bar d phi. Struggling with these phis here. of phi f. Okay? Now don't forget, that's a function of phi. So I'm going to be taking the derivative of that, differentiating that with respect to phi. All right, so let's do this now. This is equal to minus I h bar phi, because this is just a constant, right? Times, and this whole thing is times phi, df d phi. I'm going to make that a plus now, plus I h bar. Okay, now I've got to use the chain rule for this, right? So the chain rule is phi df d phi plus f d phi d phi. Okay? So this is equal to minus I h bar phi df d phi plus, looks like I h bar phi df d phi. Right, these two terms are going to cancel, you can see that. And the d phi, the derivative of phi with respect to phi is just 1. So this goes to I h bar f. Right? We're distributing that across there. I h bar f. These two terms cancel. This goes to I h bar f. Okay? And so we take the function back out of there, then it becomes I h bar. Remember, right? This is then the commutator. Still there, okay? But that's the commutator right there. Boom. And so this does not equal 0, and so therefore they do not commute, and that, of course, is the commutator. Okay? Hope that's helpful. I think that's the problem in its entirety. Again, you might want to go back to page 4. You might want to go back to chapter 17 and review what commutators mean, or watch this video again and do commutators more. The implications of this is, of course, matters in the exam when you're trying to interpret a question. So hopefully that's helpful.